Hello, I'm Dr. Ziata here. This video tutorial is solution to problem 4 by 42 from Engineering Mechanics Statics 9th edition. Statement of the problem is determine the force in member BE of the loaded truss. So need to find force in member BE. So as there is only one member force required, so the suitable method to analyze this truss is method of sections. So I'm going to use method of section to analyze this problem. So these are steps to find member force using method of section. So plan a cut. So need to choose an imaginary cut that pass through the target member, and in the member, in the cut, there must be three or less unknown member forces. So then the BE is the target member. So need to put a cut there. So that is a cut. So on that cut, so now BE is the target member, and then next one is find support reaction if needed. So support reaction are required for this one, and then choose simpler side of cut. So we need to choose simpler side of cut, either right or left side of the cut. And the selection criteria is with fewer loads reaction and fewer joints. So both sides have same joints and similar loads. Both have each one load, and right side that has a roller support, and left side as a pin support. So need to find reactions first. So to find reaction, so need to draw free body diagrams. I'm not going to draw, but just I'm going to show that reactions on that. So dy, I have assumed that upward, ay, I have assumed that upward, and ax, I have assumed towards right. And then to find reactions, I need to go for first sigma fx equal to 0 and sigma fx equal to 0. So for sigma fx equal to 0, ax is equal to 0, because here both supports are uh, aligned, okay, or both supports are horizontal and there is no horizontal load. So the reaction will be, there will be no reaction in horizontal direction, or simply as it is no action in horizontal direction, so reaction will be 0. And the condition for that is both supports should be at the same level, okay, and in horizontal direction. So the next one I'm going to do is sigma fy equal to 0, and for sigma fy equal to 0, so upward forces is equal to downward forces. So ay plus dy, both are positive, minus l minus 2l is equal to 0. So ay plus dy is equal to 3l. So I'm naming it as equation 1. So the next one I need to choose a moment point that has the most unknown. So a that has the most unknown. So then I'm going to go for further sigma m about point a is equal to 0. So now here is a dy, that is a line of action of dy, and the perpendicular distance from line of action of dy to point a is 12 plus 16 plus 20, which is 40. Then 2l, that is a line of action of 2l, and the distance from the line of action of 2l from point A is not known, because the distance, horizontal distance from A to E is not known, and then the line of action of F that is going to pass through this point, and the distance from A to F in horizontal direction is not given. So now I am going to find the distance A F dash, which I named it, and then A E dash, which I named it. So to find these distances, a lot of geometry is involved here. So starting from at point A, so the angle is 45, so that angle is 15. So the total angle is 90. So then as the total angle is 90, so this angle which AB makes with horizontal is then 30 degrees. Now this vertical line and that vertical line, so AB is going to cut that. So then the alternative angles here is 30 degrees. So, and then I have redrawn that triangle. So in this small triangle here, the angle is 15, and their angle, this angle is 15 plus 30, 45. And using sum of angles in a triangle, so this angle is going to be 120. So the next one is need to find, because uh, only that A, B, that is the distance 12 is given. So then I can find out the vertical distance AB. Vertical distance mean that if, let's say, I am going to put a line here and I'm going to name that distance as Y, and let's say I'm going to name it as B dash. Okay, so I can find AB dash using right triangle, and if that angle is 30 degrees, okay, so using that angle 30 degree, so I can find opposite. And so now in right triangle AB double dash, I can use tan theta 12 over AB double dash. So AB double dash is equal to 12 over tan 30, which is equal to 12 root 3. So now this side comes as 12 root 3. And now again using that 12, I can find AB side. So AB side can be calculated again using that angle theta, because in right angle triangle ABB double dash, so AB is hypotenuse and 12 is opposite. So sine theta is 12 over AB and AB is 12 over sine 30, so 24. So now AB side is known, which is 24. So now I actually need AF dash, and to find AF dash, I need to find AF. Now in the triangle ABF, ABF triangle, so I have all the angles and only side is 24. So then I can use sine rule to find AF, and then again I'll use sine rule to find BF. So using sine rule, A over sine A, B over sine B, C over sine C, or a side divided by sine of opposite angle, I can find AF. So AF, that is AF, and opposite angle is 45. So AF divided by sine of opposite angle to AF is 45. Then 24 divided by opposite angle to 24 is 120, sine 120. So AF is 24 times sine 45 or sine 120, which is 8 root 6. Similarly, I can find BF, and again for BF, its opposite angle is 15. BF over sine 15 is equal to 24 over sine 120. So BF comes as 24 into sine 15 over sine 120. So that is 12 root 2 minus 4 root 6, 7.1726. So now I have that AF. So using angle 45, it is possible for me to find that distance AF dash. It is possible for me to find that distance AF dash. So now AF dash is equal to AF times by cosine 45, because if I'm going to use that as a vector, so that is the horizontal component. So cosine 45, so AF is 8 root 6 times by cosine 45. So I can find that AF then. So that is by using calculator, it is 8 root 3. And similarly, I can find that FF dash, which is equal to AF times by sine 45. So F dash is exactly equal to 8 root 3 because angle is 45. So both of these sides are same. So now I have distance AF dash to find moment, And the next one, I need to find AE dash. So now for AE dash, so that distance B dash F and E dash C, both distance are same. So now AB dash distance is actually 12 and I have AF dash distance. So then I can find B dash F distance, and that B dash F distance is equal to E dash C dash. So B dash F dash is equal to E dash C dash, and that is equal to AF dash minus AB dash, which is equal to basically 12. So B dash F dash is equal to E dash C dash, and that is equal to A dash F dash minus A B dash. So AF dash is 8 root 3 and AB dash is actually 12. So then I can find B dash F dash or C, E dash C dash. And finally, I need to find AE dash. So that is AE dash. So which is equal to AC dash, and AC dash is 12 plus 16 minus E dash C dash. So 12 plus 16 minus 8 root 3 minus 12. So it is 40 minus 8 root 3. So now I have that distance from the line of action of force FL to point A, and then perpendicular distance from the line of action of force 2L to A. So now I can finally go for finding moments. So now dy is actually acting here, and dy is going to produce a moment. So this dy, when it's going to act there, so it is going to produce a moment in anti-clockwise direction. And 2L is being acting here. So that is a line of action of 2L, and that is a line of action of L. So now 2L is going to produce a moment in clockwise direction, and L is going to produce a moment in clockwise direction. So then moment about point A will become dy times by 40, 2L times by E dash, and then L times by AF dash. So then I can write that moment about point A. So now sigma MA equal to 0 dy times 40. So that is dy times 40 is in counterclockwise positive. Then 2L times by A E dash, and that is clockwise negative. And then L times by AF dash, and again is a clockwise negative. So then I have AE here, AE dash there, 40 minus 8 root 3. And then I have AF dash there, 8 root 3. So after substituting that and then taking L as common factor, so it's left with 80 minus 16 root 3 plus 8 root 3 over 40. And then after simplifying, dy comes as 1.6536 L. So the sign, then I have dy. So then AY, equation 1, AY is equal to 3L minus dy. So AY is 3L minus dy, and then 3L minus 1.6536L. So answer is positive 1.3464L. Now, a positive result confirm that assumed direction, because AY and dy both are positive. So it's mean that assumed directions are correct. So then I can write the final answer as AY is 1.3464 L in upward direction, and then dy as 1.6536 L in upward direction. So now that reactions are computed. So now after finding reaction, I'm going to choose one side. And the again doesn't make any difference if you're going to choose for left side or you're going to choose for right side. So I have selected its left side, and on the left side, the known I'm going to mention here. So show all external loads. So at F, there is one load acting vertically downward, which is L. and then at A, so there is one reaction A Y, and then member forces are B C, B E, and B F. The member forces are B C, then B E, and then B F. So I need only B E. So BC and BF are horizontal forces. So I need to find angle of BF with horizontal, and I'm going to name that as theta. So this angle theta, which BE makes with horizontal, it can be computed using triangles here. Okay. So now, to find that angle which BE makes with horizontal, so I need to select a right triangle. Okay, or simply I can just go for right triangle on here. So B and any imaginary point there, any imaginary point there. Okay, so then it will become this right angle. I am going to use that. And in this right triangle, so I need to find that B, and let's say I am going to name this as P. So BPE triangle, I need to use that to find angle theta. So, and if that angle I know, so the angle with horizontal will be 90 minus whatever angle I am going to calculate, or if so that if I will find out that PBE angle, so then its angle with vertical, I can compute that. So I have redrawn this triangle to extend that with E. So now that is a triangle. In this triangle, I know that ABB dash, and I know FF dash. So then this BP distance can be calculated with 12 root 3, and then FF dash is basically here 8 root 3. So then in the triangle, the horizontal in the triangle, its vertical distance comes as 12 root 3 minus 8 root 3 as 4 root 3. And now the distance PE, so that is equal to AE dash. So I have here AE dash minus 12. So AE dash is there 40 minus 8 root 3. So minus 12, so it becomes 28 minus 8 root 3. And in this triangle, so then I can find that phi. So tan phi is equal to 4 root 3 opposite over adjacent, and phi comes as 26.098 degrees. So now using geometry, if I know this angle and the angle EBC is the same, so that theta is equal to phi. So now once I have computed the angle, so then I can start with applying conditions of static equilibrium. So sigma m is equal to 0, and then we need to resolve inclined member into components if needed. So here AY is vertically upward, that load is acting downward. BF and BC are both horizontal, but they are not required. So then I need to find component of BE. So that is BEX, and then here is BEY. So because I have to only calculate that BE, so I can start with sigma Fy equal to 0, because there is only one unknown in vertical direction. So sigma Fy is equal to 0. So now for sigma Fy equal to 0, BE is acting vertically downward, L is acting vertically downward, and A is acting vertically upward. So both of these are negative, and then AY is positive. So it is plus 1.3464 L minus L minus BE, and that is sine theta, which is 20 equal to 0. So then BE sine theta, that is 0.3464 L, and BE is equal to 0.3464 L over sine of angle, which is 26.098. And then by using the calculator, the value comes as 0.7874 L, and the sign is positive. So now interpretation of sign is there. So a positive value indicate tension and negative value indicate compression. So then this is positive. So it's mean that while writing the answer, so BE is 0.7874 L in tension. So if you have to find other components like other BC or BF, so then you can go for sigma Fx equal to 0, and otherwise you need to find moment about point A, and to find moment about point A you need that F dash and then A B double dash. So that is all about the solution of this problem, and the answer BE is 0.787 L in tension, and that is the answer 0.7874. So 787 if you round off that. So solution of this problem. So thank you very much for watching.